For numerical data, the weighted average of all the outcomes is called the expected value for that experiment. Now, the probability distribution for an experiment is the function that pairs each outcome with its probability. So we're going to kind of combine these two, so we don't need to know all of the data, but we just need to know its probability and to help us calculate the expected value. The probability distribution for the number of accidents in a week at an intersection, based on past data, is given below. Find the expected number of accidents for 1 week. So looking at those probabilities, those are effectively percent. So like effectively 75% of the weeks there were 0 accidents. 15% of the weeks there was 1 accident, 8% of the weeks 2 accidents, and then 2% of the weeks where it had 3 accidents. So our expected value, it's going to be each value times its probability. So we got 0 times 0.75 plus 1 times 0.15 plus 2 accidents times 0.08 plus 3 accidents times 0.02. Now cleaning this up a little bit, we got 0 times 0.75, that's 0. Then 1 times 0.15 is 0.15, 2 times 0.08 is 0.16, and then 3 times 0.02 is 0.06. Add those all together, we end up with 0.37 accidents per week. Now, one kind of tricky thing with the labeling of this, it's called an expected value. That's like saying we expect 0.37 accidents per week. Though that doesn't quite make sense. You can't have 0.37 accidents per week. It's really just a weighted average. Now, this next part is hopefully something you've seen before. A box and whisker plot shows the spread of all data in a set. It displays 5 key points, the minimum and the maximum, so the highest and lowest values. The median, we already found that. And these things called the first and third quartiles. Now, the first and third quartiles are the medians of the upper and lower half. So the median divides the whole data set into 2 halves. So we got the medians of the upper and lower halves. So when the median cuts the data in half, then you can look at the top half, like the ones that are higher than the median, and then the lower half. The interquartile range is going to be the distance between your quartiles. And we'll call those, you'll notice up top we have those Q1 and Q3. The way we're going to calculate that is the IQR is equal to Q3 minus Q1. So just looking at the distance between your quartiles. For this example, we have a set of data here. We're asked to find the box and whisker and also the interquartile range. Now, in order to do so, we should probably put this in order. I've already done that. We got 4, 5, 6, 6, 7, 8, 8, 9, and 10. Now, I know a lot of us when we go through this, we kind of like cross off the first and last to find the median. Now, in this case, what I'm going to kind of do is kind of like, I can't show 2 arrows at once, but I'll kind of like, we cross off this one, the second to last, and as you go through it, you're going to find out that you end up with just one value in the middle. So in this case, our median is just that value of 7. Other key points we're going to need are our minimum, which in this case is 4, our maximum, which in our case is 10, and then the quartiles. In order to find our quartiles, what we're going to do is we're going to look at the lower half and the upper half separately. Now, that 7 is not in the lower half, nor is it in the upper half. So for the lower half, we're going to find our median of the lower half falls right there. We're going to say this is a Q1. Again, this is our median. And then for the upper half, let me clear this out here. The upper half, the median is going to fall right between 8 and 9. So Q1 ended up falling right between 5 and 6, so the average of that would be 5.5. For Q3, it'd fall right between 8 and 9, so it'd be at 8.5. You'll notice we have Q1, Q3, we don't talk about Q2. Well, Q2 is technically the median. Now, if we're going to make a number line out of this to kind of show our overall box and whisker plot, you don't need to include every number on here. I would include at least the bare minimum of your median. So we got 7. And I'm just going to go 8, 9, 10 because we got to go up to that. And then we got to go down 6, 5, and 4, our lowest value. Now remember, for box and whisker plots, we're going to put a dot at the minimum and a dot at the maximum. We're going to draw a line at the median median, sorry. We're also going to draw a line at the first quartile, so halfway between 5 and 6. We're going to draw a line at the third quartile, halfway between 8 and 9. And we're going to make that into a box. Then we're going to connect the box to the whiskers. Now the last thing we need to answer for this one is the interquartile range. Remember that's Q3 minus Q2, so it's going to be, sorry, Q1, goodness, 8.5 minus 5.5, which gives us an interquartile range of 3. The significance of that is approximately 50% of all the data is within 3 of each other.